Okay, let's try to evaluate these limits, okay? But like keep that in mind. What was the first step to evaluate the limit? That is the plugging in, okay? And we're gonna try to plug in -3 into this fraction form, okay? Then what is that? When you plug in -3 into your numerator, -3 squared is 9, and plus 3, which is 12 minus 12, oh, it is 0, over 0, okay? So, well, what about this value? 0 over 0 equal to 0? No, you cannot do that, okay? What about like, since we have like, 0 on your denominator, is it undefined? Well, the answer is I don't know. That's why we say the name of this form is indeterminate form. Which means we cannot decide the value, the value of this limit value, okay? So what are you gonna do? But keep that in mind, since you have like 0 over 0 form, which means you have like 0 factor on your numerator and 0 factor of your denominator. What is 0 factor? Where we have like 0 over 0 by plugging in x equal to -3, which means x plus 3 is the 0 factor, okay? Definitely look at your denominator. Oh, there is x plus 3, told you, right? But what about numerator? You must have x plus 3 as a 0 factor, okay? And I can show it to you, okay? Here we go. So like to see like what I have, like, 0 factor on your numerator, and we're going to the factor, okay? Guys, whenever I draw the snake, that is LIM, okay? For limits chapter, I keep writing that limit notation instead of like LIM, okay? So look at numerator, okay? It is x plus 3 and x minus 4. Dun, dun, dun. Your 0 factor is now visible. Does it make sense? Now, since we're going to evaluate the limit, we have to cancel this, guys. It's okay? So now, like, troublesome is gone, okay? So this is equal to limit x goes to -3 and x minus 4 over 1, okay? So now there is no problem to plug in -3, right? Plug in -3, -3, -4 over 1, which is -7. That is the answer for this limit, okay? And we're going to do the same thing for like number B, okay? So look at that. Well, but you have to be careful. Whenever you plug in 1, it is not equal to 0 over 0 form. So we are not going to do it like this way, okay? So here we go. Just plug in 1, what happened? 1 squared minus 1 minus 2 over 1 plus 1 is equal to -2 over 2, which is equal to -1. So, well, like this is the way to evaluate like your limit, okay? If it's not indeterminate form, okay? But you have to remember why it happened for like differently in problem A and B, okay? Problem A is discontinuous at x equal to -3, okay? That's why you have to do like this way. And it's like it was like indeterminate form, okay? But B is continuous at x equal to 1, which means your limit value is always equal to your function value. That's why we can evaluate your limit value by just simply plugging in x equal to 1. Does it make sense? Okay, we're going to talk about the detail of this one in continuous part, okay? Here we go. Let's talk about a little bit complicated problem, okay? So like, anyway, whenever you have to evaluate the limit, and the first step is no matter what, plugging in. We're going to try to plug in t equals 0. And when you plug in t equals 0, what happened? Look at that. When you plug in t equals 0, and your numerator is square root 2 minus square root, oh, it's equal to 0, right? Denominator is automatically 0, right? Which is indeterminate form, okay? But in the previous problem, I said whenever you have indeterminate form, you must have 0 factor on your numerator and denominator, okay? But this case, since we're going to plug in t equals 0, t itself is your 0 factor. Oh, I have t on my denominator. But what about numerator? I don't have t term in numerator, right? But it is inside of like square root, right? But that's why we need one important technique for this problem, okay? We will multiply the conjugate. Is it okay? So let me show it to you, okay? Here we go. Let me rewrite my problem here. Limit t goes to 0 and square root of 2 minus t minus square root 2 and t, right? As I told you, we're going to multiply some special function form, not function form, but conjugate form, which is square root of 2 minus t, plus, this is conjugate, okay? Whenever you multiply something to numerator, then you have to multiply same thing on your denominator as well. 2 minus t plus square root of 2. Is that clear? Okay? Then let me simplify this, okay? Equal to limit t goes to 0, okay? Let me give you one important tip for this, okay? When you simplify this one, and you're going to take care of numerator, but don't do anything for your denominator, okay? Just write again with the parentheses. And then look at numerator. Square root of like 2 minus t minus square root 2, and same thing but plus. Do you remember this, okay? It's from high school, right? I just want to make sure about like you understand this, okay? It is the case a minus b times a plus b, which is a squared minus b squared. It is just simple distribution, okay? But like, you should memorize this one like for faster process, okay? Here we go. Then what happened? For first term, which is square root of 2 minus t squared minus second term square, okay? And square root and square root, okay? It will come, okay? So let me write here. Keep continue. T goes to 0. And again, don't do anything for your denominator. Just write again with the parentheses. Don't do any distribution. But what about numerator? 2 minus t and minus 2, okay? Then can you find this one? It always happens, this one. I will explain about this one later in differentiation definition, okay? This skill again, okay? But anyway, we're going to do like this way, and then equal to, still t goes to 0, and my numerator is negative t over t times square root of 2 minus t plus square root, okay? Dun, dun, dun. Do you remember? If it is indeterminate form, you must have zero factor on your numerator and denominator, okay? Which was t. Now it is visible. Then since it is visible, what are you going to do? I'm sorry, gone, okay? So this guy, let me keep writing your limit because like we didn't take care of limit yet, okay? So negative 1 over square root of 2 minus t plus, so since we cancel out the zero factor, there's no problem to plug in t equals 0 now. It's okay? It's not indeterminate form anymore, okay? Just plug in t equals 0 simply, and that is equal to, now we don't have to write the limit again because I use the limit by plugging in, okay? So it is square root of 2 minus 0 plus 2, which is negative 1 over square root of 2 plus square root of 2, which is negative 1 over 2 square root of 2. That's it. This is sense, okay? But if you want to do the rationalized denominator, you can multiply this guy. Then your final answer is negative 2 over 4, okay? It is option, okay? But anyway, you can do like this, right? Let me give you another special case, okay? Before to take care of this one, but you have to double check by plugging in h equals 0. Because as I told you, like always, the first step to evaluate the limit is plugging in your limit value, okay? We're gonna plug in h equals 0, what happened? Since h equals 0, your numerator is like 3 to the negative 1 minus 3 to the negative, which is equal to 0, right? And 0, dun dun dun, it is still indeterminate form, okay? But again, whenever you have indeterminate form, you must have zero factor, which is h, right? And it is visible on your denominator, but like it is invisible on your numerator. Now, I'm gonna teach you how we can find the zero factor of your numerator, okay? Here we go. So, well, okay, like since negative power means reciprocal, so like 3 plus h to negative 1 means 1 over 3 plus h, right? So let me rewrite this problem with fraction form, big parentheses, and 1 over 3 plus h, and minus 1 over 3 over h, right? It's okay, but like it's a little bit complicated, right? We say this complicated fraction form as compound fraction, okay? But there are many different ways to take care of this one, but let me try to teach you with a silly way, okay? And what I'm gonna do is I'm gonna push your denominator. I'm talking about this guy, okay? And push this out, okay? Then this guy can be written by limit h goes to 0. Let me use like parentheses for your numerator, and this one came from here, just pushed out. Does it make sense? So like in here, we have this guy, okay? And like, this doesn't make sense, okay? So we can do like, separate your numerator in there and denominator like this way. It's okay? It's the same thing, okay? So now what we're gonna do is we're gonna do the common denominator of these two fractions. Does it make sense? Okay? So here we go. Equal to limit h equals 0, okay? Again, you have to keep writing this limit, okay? It is 1 over 3 plus h, and let me give some space because we're going to multiply something. Negative 1/3 and another space, and 1h came from big denominator, right? So to make it like this 2 has this common denominator, we're going to multiply something, okay? So for the first term, we're going to multiply 3 over 3, and second term, is that okay? Then they will have the same denominator, which means we can combine as one single fraction form. Let's do it. Here we go. Over here, equal to limit h goes to 0. In the parentheses, it will be 3 over, okay, again, we are not going to distribute this, okay? We're going to write as like 3 times 3 plus h form with the parentheses, okay? And what about the second one? 3 plus h over 3 plus h. And 1 over h is outside. Is that clear? So look at that. They have same denominator, then we can combine as one single fraction, okay? But for that process, be careful about this guy, okay? It is fraction and there is negative here, which means it must be distributed, okay? So here we go. Equal to limit h goes to 0. Now big denominator. Since like it is common denominator, we can combine your numerator, okay? 3, again, this negative must be distributed, okay? That is important. We are here now, okay? It's really clear, right? Now, that already happened, okay? So, let me rewrite this only here. Limit h goes to 0. And now, I have negative h only on my numerator, and 3 times 3 plus h here, then we have 1 over h outside. Look at that. As I told you, now your zero factor of your numerator is visible. Then whenever it's visible, then we're going to cancel out with the denominator. Is it okay? So let me keep writing, okay? But again, you have to keep writing your limit, okay? Because we never used this one yet, okay? Negative 1 over 3 times 3 plus h, okay? Now there is no problem to plug in h equals 0 because we cancel out the zero factor, okay? So it is equal to negative 1 over 3 times 3 plus 0, which is negative 1 over 9. This is your limit value. Here we go, getting worse, right? So like in a previous problem, it was function, but now it is vector function, right? But don't worry about it, okay? Your limit is working for component-wise. So you're going to take the limit for x component and take the limit for y component separately, okay? So here we go. So this limit means limit t goes to 1 to t minus 3, x component, and separate the limit for your y component as well, t squared minus t and t minus 1. That's it, right? So first part, x component, okay? Well, it is continuous function and there's no problem to evaluate by plugging in, right? So plugging 1 in there, that is equal to 2 times 1 minus 3, which is equal to negative 1. We done the x component, right? What about y component? Well, again, same thing. Okay, we're going to plug in 1 in there, but you can easily find that is indeterminate form. Dun, dun, dun. Then we have to cancel out your zero factors, right? Which is t minus 1, okay? So look at your numerator. It's easy, right? Here we go. When you factor t out, t minus 1 and t minus 1, then now I can cancel out my zero factor. Then it is simply limit t goes to 1, t over 1, which is equal to 1. That's it. So your answer is -1, 1. That's it.